do are composites. And there's two pieces to composites. There's doing the calculation, which is an algebra function, and then there's domains. So there's these two pieces. There's when we do plus, minus, multiply, and divide of functions, and then there's what we do, true composites, which would look like this. Okay, with regards to these, if I gave you f of x equals x plus 2 and g of x equals x squared plus 1, if I told you to do f of x plus g of x, well, you're going to add those two, and then you're going to combine like terms, so we get x squared plus x plus 3. We're just following combining like terms. F of x minus g of x means we're going to take f of x, which is x plus 2. We're going to subtract g of x. Now you got to be careful to make sure you distribute the negative. So we get x plus 2 minus minus, so it's plus x squared, minus plus, which is minus 1. And then we can go ahead and combine like terms. We get x squared plus x plus 1. And for multiplication, we can do f of x times g of x. So we're going to end up with x plus 2 times x squared plus 1. And you wouldn't FOIL this. I need you to FOIL this out for real. And then there's f of x divided by g of x, which is x plus 2 over x squared plus 1. And that can't be simplified. So the plus, minus, multiply, divide is pretty straightforward. For the domain, though, when I ask you for the second part, it's going to be what's the domain. For the domain of these, okay, just these, we're talking plus, minus, multiply, and divide. You do the domain, you take the domain of f of x is domain. You take g of x as domain. And you take your answer and its domain. And the domain of your final solution is taking all three of these and indicating what is acceptable to all three. So in the case of f of x, there's no restriction, it's all reals. In the case of g of x, there's no restriction, it's all reals. And in the case of the addition, your answer, there's no restriction, it's all reals. So we're talking about all reals, and all reals, all three pieces. So the answer, final answer for the domain here would be all reals. Same thing is true in f of x minus g of x. All reals for f of x, all reals for g of x, and all reals for the answer. So the answer, the final domain is all reals. That will change here with f of x over g of x. While the domain of f of x is all reals and the domain of g of x is all reals, there is a value of x in the denominator that if you were to assign that value of x, you would get a 0 denominator. I'm not going to do that calculation, but if we have all reals for f of x and all reals for g of x and a restriction on x in our answer because of the division, then your final domain would be all reals except those two values of x that make the denominator 0. All right, let's take the same f of x and g of x. Remember, if we do f of g of x, we basically are saying take f of x, which is x plus 2, and everywhere we see an x in f of x, substitute in g of x. All right, so f of x is x plus 2. I get an x. I'm not writing x. I'm going to put x squared plus 1, and then plus 2. So my answer is x squared plus 3. Again, everywhere in f of x that I see an x, I'm going to put in g of x. So instead of writing x, I'm going to write x squared plus 1, and then I continue. If I ask you to do g of f of x, start with g of x, and everywhere I see an x in g of x, I'm going to substitute in f of x. So I would get x plus 2 squared plus 1, and then you would FOIL that out, and you would get x squared plus 4x plus 5. All right, now the only difference in domain between plus, minus, multiply, divide, and composite is for the domain now, you're going to take the domain of the inner function and the domain of your answer. And you're going to make sure your final domain is what's acceptable to both of these. So whereas in this case, you're taking f of x, g of x, and your answer, in the case of these composites, you're only interested in the inner and the answer. So let's go back to this first one. If I said, what's the domain of my answer, my true final domain? Well, the inner function is g of x. The domain of g of x is all reals. And the domain of my answer is all. So my final answer domain for f of g of x is also all reals. So in the case of these composites, again, you're looking at the inner function and the answer. In the case of plus, minus, multiply, and divide, you're looking at f of x, g of x, and your answer. 3 pieces here, 2 pieces here. Hope that helps. Good luck.